Wait, I didn't get my stuff back.
Set 6A. Did everybody get a paper?
No.
Okay, here we go. Focus.
No.
All right, 6A-2. Simplifying radicals. Okay, so this is the new step. Okay, so the last section, Levi, put that, stop, because that's not how you do it. Okay, the last notes, all right, was more review. Then this is the new stuff. Okay, you had to learn how to do the birthday cake method before you could do radicals. All right, so for review, we're going to fill out this side first. Everybody knows square roots, right? Okay, square roots. So the square root of what number would give me 1? Okay, well, let's talk about it. All right, so how we do this is we say that 1 squared is what? 1 squared is what? It's really just 1 times 1. Well, what's 1 times 1? 1.
2.
Okay? Then I could say 2 squared is 2 times 2, which is 4. And that would be the answer. Then I say 3 squared is 3 times 3 is 9. Okay, you get what I'm doing here? 4 squared is 4 times 4, which is 16. What would be the answer to 4 squared? Okay, now, this is on the back, all right? You don't necessarily have to write this down, but I do want to talk about it. So now we're going to work opposite, okay? What if I gave you the box numbers? What if I say the square root of 1 is, well, what is the square root of 1? What 2 numbers that are the exact same multiply together to give me 1? 1. So if I said the square root of 4, well, what 2 numbers are the exact same that multiply together to give me 4? 2. The square root of 9. What 2 numbers are the exact same? Okay, 3. Because look right here, 3 times 3 is 9. 2 times 2 is 4. 1 times 1 is 1. Then I could even go to 16. The square root of 16 is 4. Okay? Then you could do square root of 25 is, well, 5 times 5 gives me 25. Okay? So the opposite of squaring something. So if I square something, the opposite of squaring it is square rooting. Just like the opposite of adding is subtracting, the opposite of multiply is dividing, the opposite of squaring is square root. Okay? So these are perfect squares. So the square root of what is 1? 1. Or you could say 1 times 1 gives me 1. The square root of what is 2? 4, because 2 times 2 is 4. The square root of what is 3? 9, because 3 times 3 is 9. The square root of what is 4? 16, because 4 times 4 is 16. The square root of what is 5? 25, because 5 times 5 is 25. Square root of what is 6? 36. Because 6 times 6 is 36. The square root of what is 7? 49. You guys got it? 7 times 7 is 49. The square root of what is 8? 64. Square root of what is 9? 81. The square root of what is 10? 100. 11. 121. 12 is? Okay. You should have those memorized up to 12. Just from common knowledge of being in math since in kindergarten. Okay? Off the top of your head, you should have those memorized. Okay? Now, the rest of them are a little bit more difficult to remember because it's a little bit higher up. Okay? But 1 through 12, you should know. If I say square root of 144, you should automatically know that it's 12. Okay? So, 13 is 169. 14. 196. 15. 225. 16. 256. 17. 289. 8 is 324. 19 is good, 360. And 20 is 400. Are perfect squares, meaning that two whole numbers, the exact same numbers multiplied together, will give you one of these perfect squares. Okay, what I mean is 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Okay, that's the perfect squares. Now, look at example 1. Is 108 a perfect square?
No.
Well, if I go down here, it's 108 is between 100 and 121. Well, that's not a perfect square. So 108, the square root of 108, does not have two of the exact same numbers that multiply together to give you that number. Okay? So if I put the square root of 108 in the calculator.
10.3.
So the square root of 108 gives me 10.3. It gives me a decimal, okay? Well, right now, I don't want decimal answers, okay? We want radical answers, square root answers. So what I'm going to do is I'm going to break 108 down as far as possible, okay? We're going to break it down as far as possible, just like the birthday cake method. All right, we're going to use that to help us. And then we're going to take it one step further. Okay? So I want to break down 108 as far as possible. And I told you that we're going to use the birthday cake method. So here we go. 108. That's what I'm trying to find the prime factorization of. So I'm going to start at the bottom. Okay? And this is just like what we did, okay, on these notes right here. So if you want to use this to help you, you can, all right, your little chart. So if I'm going to find the prime factorization, I start with my first prime number. Can 108 be divided by 2? Yes. And what is its answer? 54. Then I do 54. Can it be divided by 2? Yes, and I get 27. Then I say, can 27 be divided by 2? No. So then I move to the next prime number, which is 3. Can 27 be divided by 3? Yes. And what's its answer? 9. Can 9 be divided by 3? Yes. And what's its answer? 3. Can 3 be divided by 3? Yes. And its answer is 1. And I got my birthday candles at the top, so I'm done breaking it down. Okay. Now we're going to take it one step further. Okay. This is not going to be my answer, just like it was last time. All right? What we're going to do is we're going to talk about a date. Okay? We're going to talk about a date. So, in order to leave the house, if you're going to go on a date, you have to have what?
Nice clothes.
No,
Money.
Another person to go with you, right?
Oh.
It's got to be two.
Your dog.
Okay? It's got to be another person to go with you if you're going to go on a date. So what I want you to do is I want you to draw the house. This is going to be our house, and that's what I'm going to call it. The square root symbol is going to be your house. Okay, so everybody draw your square root symbol. That's going to be your, in quotes, house.
You got a foundation.
Okay? Now, in order to leave the house, you have to have a date.
Door.
A date. Silly heads, okay? In order to leave your house, you have to go on a date.
You can go by yourself,
Okay?
yeah, right?
No, you can't. If you go by yourself, you have to stay at home. So, in order to have a date, you have to have a pair, the same number. So, let's look over here. Now, these right here, listen, these are the only numbers I'm looking at. Okay? So, if they have a pair, they get to leave the house. So, let's see right here. These twos, they have a pair. So, they get to leave the house and go on a date. All right? Now, when they leave the house and go on a date, they fall in love and become one number. Okay? They're going to become one number. So these twos are going to fall in love and just become 1, 2. Outside the house.
They make a baby.
Okay? All right. Then, here are 3s. These threes are going to go on a date because there's two of them. They're going to leave the house, fall in love, and become just one 3. Okay? So times 3 out there. So this 2 outside the house and this 3 outside the house, they had a date, and they got to leave the house and become 1. Okay? They fell in love. Now, notice this 3 right here. Does it have a date? No, everybody else is already matched up. They're already on their date. So this 3 doesn't get to leave the house. He has to stay home, okay? So this 3, because he doesn't have a date, he's going to go home. He's going to stay at home.
You don't have to be lonely.
Okay? All right. So all the numbers highlighted got put somewhere over here. All right? Now, I'm not going to leave it like this. What is 2 times 3? 6. Okay? And then this 3 is by itself under the house, so it's just going to stay by itself under the house. And that's my answer. Okay? Got it? Okay? So there were 2 numbers outside the house. Because there was 2 dates, there's 2 numbers outside the house. They got multiplied together to give me 6. There's not another number to multiply. 3 just gets brought down. Okay? Everybody?
Expose the 3 like that.
Oh no, 4, 3. Okay. Look at example 2. The square root of 289. Is that a perfect square?
Yes.
Look right here. 289. What's the square root of 289? 17. So this one's easy. It has a perfect square, so that's its answer. Okay? Number 1 does not have a perfect square, so we had to break it down as small as possible. Okay? Number 2 has a perfect square, so that's its answer. Okay, number 3. 288. Is that a perfect square?
No.
No. So now I got to break it down by using the birthday cake method. All right, so we're going to start at tier 1 of the birthday cake. 288, right small. Okay, start with your first prime number. Here we go. Can 288 be divided by 2?
Yes.
Yes. And what's its answer?
144.
144. Can 144 be divided by 2?
Yes.
Yes, then it is?
144.
72. Okay, that's right. Can 72 be divided by 2?
Yes.
And its answer is?
36.
Can 36 be divided by 2?
Yes.
Yes. And its answer?
2.
18. Okay. Can 18 be divided by 2?
Yes.
Yes. And it is?
9.
Can 9 be divided by 2? No. Okay, so I go to the next prime number, which is 3. Can 9 be divided by 3? Yes. And its answer is?
3.
Can 3 be divided by 3?
Yes.
Yes. And its answer is?
1.
1. And I got my birthday candle on top, so I'm done. Okay, now, draw your house. Okay, if it's a date, if there's a pair, they're going to go on a date, fall in love, and leave the house, okay? Make sure you circle your dates, okay? Circle your dates as you go. So right here, here's my first date, these 2s. They're going to fall in love, they're going to go on the date, leave the house, and become 1 number. Okay, then there's another set of 2s. They're going to fall in love, leave the house, and become 1 number. Okay, now, does this 2 right here have a date?
No.
No, so where does he have to go? He has to stay home. Okay? Okay, then I've got a date of 3s, so where do they go?
Outside.
They're going to leave the house, fall in love, and become 1 number. Okay. Can this be my answer?
No.
Now I have to do the multiplication. 2 times 2 is?
4.
Times 3 is?
12.
So 12. 2 is alone in the house, so he just gets brought down. How are we feeling? Okay? Okay. Example 4. Is the square root of 64 a perfect square?
Yes.
Yes, and what is it?
8.
8. So that's its answer. Okay. What's different about 5?
That's a negative number.
It's got a negative. Negative what?
3.
Negative 3 out there. Okay, so let's talk about what we're going to do. We notice that it's different. Okay? So, when we get to this part right here, and we're multiplying all the numbers on the outside, okay? When we get to this part, when we multiply all the numbers on the outside, we're also going to multiply a negative 3 out there. Okay? Does that make sense? Okay? I'll show you when we get there. But once we get to here, we're just going to put a negative 3 out here as well and multiply it with the rest of the numbers on the outside because it's already on the outside here. Okay, now, it's really important that you don't forget about the negative 3. After you do the birthday cake method, it's really easy to forget that there's another number out here. So what I want you to do is I want you to go ahead and start with this negative 3, all right? Put your house, and we're going to already have that negative 3 out there, okay? So we don't forget it. So if you see a number out there like that, go ahead and draw your house and put him on the outside because he's already outside, just so you don't forget him, okay? Now, then I ask myself, is the square root of 192 a perfect square?
No.
No. So what do I need to do? I need to do the birthday cake method. And write small. Okay. 192. Can it be divided by 2?
Yes.
Yes. So what's your answer?
96.
96? Okay. Can 96 be divided by 2?
Yes.
Yep. And you get?
48.
Good. 48 be divided by 2?
Yes.
Uh-huh. 24. Can 24 be divided by 2?
Yes.
Yep. And you get?
12.
12. Can 12 be divided by 2?
Yes.
Yes. And you get? 6. Can 6 be divided by 2?
Yes.
And you get?
3.
Can 3 be divided by 2?
No.
No. So now I got to move to the next prime number, which is
3.
3. And it can be divided by 3 one time with my birthday candle. So make sure your cake looks just like mine. All right. Now we got to pick which numbers are going to fall in love and leave the house. Okay? Here we go. One at a time. I got a 2 out here. They're going to go on a date, fall in love, and leave the house. Then I've got another set of 2s. Go on a date, fall in love, and leave the house. I'm going to run out of room up here. Then I've got another set of 2s. Okay? Fall in love, leave the house, become one number. Okay? And then I've got 1 3. So what's the 3 got to do?
Go in the house.
Go in the house. He's got to stay home. Okay, then I can just use my calculator and multiply the numbers on the outside. 2 times 2 times negative 3 times 2, which is negative 24. 3's by himself, so square root 3. Okay, let's talk about something real quick. Let's say you get to this point right here. Okay, let's say you get here. 2 times negative 3 times 2, square root 3, and there were 2 single numbers that had to stay home. Okay, because you'll have one like this on your homework. If there's 2 single numbers that have to stay home, they don't have a date, you just multiply them inside the house, and then multiply the outside. And that would be your answer. Okay? Okay? Does everybody understand? You multiply the outside, then you multiply the inside. If there's more than one single person that has to stay home. Okay, example 6. Last one. Okay, notice that there's a negative 2 out there. So what do I do?
Leave it.
Okay, we need to circle it.
Oh.
Alright, and don't forget it. Okay? Then, is the square root of 144 a perfect square?
Yes.
Okay, so what is the square root of negative 144? What is the square root of 144? 12. But what about this negative 2? What do I need to do? Is 12 in the house? Does 12 have a house?
Multiply it.
Answer the question. Does 12 need a house?
Yes.
Did 8 have a house when it was a perfect square?
No.
Does 289 have a house?
No.
Do any of these numbers that are perfect squares have a house?
No.
No. So does 12 need a house?
Yeah. No.
No. Okay, so 12 is outside the house. Well, what else is outside the house? Negative 2. And we're going to multiply. So what is negative 2 times 12?
24.
Negative 24. Okay? If it's a perfect square, you no longer have a house. Okay? I'll say that one more time. If it's a perfect square, you no longer have a house. Any questions?
Nope.
Are we good?